Okay, here's lesson 5.2. We're going to solve exponential equations, and we're going to do this two ways. So you see a way here, base A, and then we have B. And so let's do A first. So what we'll do with exponential functions, when the bases can be written, oops, sorry, it's highlighter, can be written with same bases. These are the steps you want to take. First, you're going to isolate the bases, or base. Put that like that. We're going to rewrite as a common base, or as common bases. Okay, and then just a side note, don't have to do that, but using smaller base is sometimes, like I was saying in class, I don't like the word better, but sometimes it's better. It just depends on you. So like for example, what I mean from here, 4 and 16 can be written in two ways. We can write with base 4, and we would get 4 to the first power, and this is going to be 16 squared. Or you can do base 2. So this would be 2 squared, and this would be 2 to the 4th. Sorry, that square looks terrible. But doing that way can sometimes help you to make it less work at the end. Sometimes it doesn't matter, okay? But just know that you can, the smaller base, maybe more efficient, I don't know, but sometimes it's just the word better. Okay, so then we're going to set exponents equal to each other as the last step. Get rid of those bases, and we talked about that. And set exponents equal to each other. Then solve for x. Okay, so remember, when those bases are the same, you're able to drop the exponents and set them equal to each other. There's a lot of different ways you can do that. So we did that with evaluating logs. So it still applies when we do other ways. This is exponential equations or functions. So the first thing we're going to do, we're going to look at this. I want to pay attention to, can I have the bases the same? Can I change them to be the same base? So this is an 8, this is an 4. Now I want to know what the common base would be. So what I'm going to do is I'm going to write it here. My common base for these two would be 2. Okay, so I'm going to change those to 2's. 1 over 8 is really 1 over 2 cubed, and that's raised to x plus 1. But remember, when you have a negative, when you have a fraction, you want to change that to a negative exponent. So sorry, that looked like a 23. 2 cubed. So now we're going to change this to a negative exponent. And so when I do that, I'm going to get 2 to the negative 3. But I still have this x plus 1 here. So I'm just going to do that in a different color so we see that all I need to do is multiply to that. And that has to equal, and I'll change this base to 2 squared. Now we're going to drop the bases. Okay, so these are going to cancel out by setting the exponents equal to each other. And we're going to have negative 3 times x plus 1 equals 2. Okay, so now solve for x. So that's going to give me a 5 right there. Divide by negative 3. X equals negative 5/3. Okay, let's go to number 2. All right, number 2. Okay, first find, if you can see, 27 and 9 do have a common base of 3. So here my common base will be 3. Now again, I have this fraction right here. I'm going to change it to a negative exponent. So first I'm going to write it 9 is 3 squared. So this is actually equal to 3 to the negative 2. So I have 27. I'm going to change to base 3. So this is 3 cubed times what's up here equals 3 to the negative 2 times what's in the exponent. Okay, now that the bases are the same, we can drop the bases and set them equal to each other. So I'm going to do that so you can see it. Equals negative 2 times 2x plus 1. So I'll pause the video, come back and check. Okay, so I'm doing your math and solving for x. I got x equals 10/7. Okay, so try to show the steps there so you can see it. So let's go to number 3. Okay, so number 3 is a little slightly different. Yes, I do have fractions, but the other ones I had 1 over 8 or 1 over 9. Here I have a 3/4 and a 16 over 9. So hopefully you recognize that 16 over 9 is just 4 squared over 3 squared. So my common base this time is a fraction. So it's going to be, again, I'm going to use a smaller one, 3/4. Okay, so now I can change these. So if I think about 16 over 9, is the same as 4 over 3 squared, but it needs to be 3/4, so that means I need to flip it. So remember, when you flip it, it becomes 3 over 4, and the exponent becomes a negative 2. So now, here I have 3/4 raised to x plus 2 equals 3 halves, fourths, raised to the negative 2 times that 3 minus x. All right, so set the exponents equal to each other and solve. And check your answer in a minute. So after doing all the math, my solution is x equals 8. Okay, so again, this is a little different. Just look at your common base, flip when necessary, make sure that the fractions are the same. Okay, let's go on to number 4. Now number 4 is a little bit different. It's not isolated. Every time I had some, it's always some base equals with an exponent or such. This is not isolated, so we have to create it, we have to get it isolated. So this is what we're going to do with step number 1. And what we want to do is get that base of 3 by itself. So if it was solving, it was like 6 times x, I need to divide both sides by 6 to get rid of the number in front of the exponent. You cannot multiply 6 times 3. Order of operations does not allow us to do that. That 6 is not inside the parentheses, so it's not being raised to the 2x plus 3. Now that I've done this, I have a common base of 3. Okay, so I'm going to stop the video, do the work, and then you come back and check. Okay, so after doing the math, set them equal to each other, I changed 9 to 3 squared, drop the exponent, the bases, drop the bases, and then I set them equal to each other and solve for x. Okay, let's go on to the second way of solving exponential equations. Okay, second one, we have bases that cannot, I don't know why it keeps moving on me, cannot be written with the same base. We have to do the following steps. First, isolate if necessary, just like we did on the above state. Problems, isolate. I'm having a hard time writing the base or bases. Okay. Then rewrite in log form. And this part, when we get to this part, is when you're going to have to use a calculator majority of the time. And then number 3, solve for x. Okay, so let's look at our first example. Okay, so for these examples, when they're not the same base, this is what we're going to do. First, we're going to solve the following for x algebraically. Make sure you show all the necessary steps. Very important that you do that. If we look at number 1, base e and e cannot, this 4/5 can never be written with a base e. They're not the same. You can't manipulate the problem to do it. So we're going to have to follow the steps. So the first thing it asks us to do is to isolate, okay, the base. Well, this is the base here, so it's isolated. Okay, so now we'll go to number 3, was it? Number 2, sorry. And then we're going to rewrite them as rewrite it in log form. So our base is e. So we're going to take, so if we're going to write in log form, that means I need the natural log, which is base e, of the argument equals the exponent. The log always equals the exponent. Now, this right here is a number. Natural log of 4/5 is a number. So if I wanted to solve for x, I need to move that over to that other number. So I'll subtract 1 from both sides. Well, these are not common, so you cannot combine these like terms. They're not like terms, I should say. So you cannot combine them. So I'm just going to put the 1 next to it, and that is going to equal x. Now what we need to use is use our calculator at this time to solve for x. So with this one, we use our calculator and we get an answer. Go to 3 places. You're going to get x is approximately negative 1.223. For number 2, we need to isolate this base. Okay, they're not in a way that I can actually see what my base might be. I still have a lot of math to do with it, so I'm going to isolate that. I'm going to first move the 10 over. That's 2 times 5 to the 3x. Again, you can't multiply the 2 and the 5 together. It's going to be 14. And next I will divide by 2. So 5 to the 3x equals 7. Now at this point, check, can you write the same base? Is 5 and 7, can you remember make the same base with that? No. So you're going to have to change it to log form. Okay, so there are no common base. So now I'm going to change it to log form. So my base here, though, for this one, base is 5. So it's log base 5 of 7 equals 3x. Remember, the log always equals the exponent. So now, with this way, I'm going to solve for x like I would do a normal problem. This log base 5 of 7 is a number. There's no variable in it, so I can put my calculator and it'd come out some decimal answer. So if I was solving for x, I would divide both sides by a 3, and then x will equal log base 5 of 7 over 3 equals x. So now I'm going to put that in my calculator. So you're going to go to math, make sure you're on the home screen, math. Then you'll go to the A, and you'll see something that shows you log base, and then hit enter. Now, one thing nice about that is when you show it in your calculator, you'll see that it's nice and pretty for you. It'll show up with a log, and then you're going to put something here, and you're going to put something here. So that, and then you're going to divide by 3. So log base 5 will be in there in 7, and then divide by 3. And you'll get approximately 0.403. So make sure that you round 3 places. For the next one, number 3 here, we're not going to do this. We're going to actually do this in 5.3. So move to 5.3. Okay. Okay, so what we're going to do, we're going to graph these, this function to solve it graphically instead of using algebra. So the first thing, just a few steps, the first thing you have to do is put one side of the equation into y1 in your calculator, that y1 equals, and then the other side into y2. That looks like this kind of thing in your calculator. So this side here, I'll label this y1 and this side y2, okay? And then the second thing you'll do is that you will graph and adjust the window if you need to. Graph, and then adjust the window if necessary. Okay, this is to allow you to see the intersection. Run out of room. Intersection. Also make sure that you can see your cursor. Move your cursor according to. Okay, and then the last thing is you're going to use intersection to find your solution. And we've done this before in another lesson, and we've done this before in Algebra 2. So let's look on how we do this. So the first one I'm going to do is I'm going to do y1 and y2 in both of those. So I'm going to go to my calculator, and I'm going to clear this out. Okay, and in my calculator here, I'm going to do that y2, that on y1 I'm going to do 2. And you can go to second natural log of natural log, and there's the e to the x. And then you can put the x plus 3. To make sure you're out, go down, minus 5, hit enter. And then you're going to put 7 in the other one, and then hit enter. So go to graph. If you've been messing with it, hit zoom 6, okay? So if you notice here that my my graph, I can see my intersection. I'm trying to look for my cursor. So second trace. So now I got to find the intersection. Second trace would be a 5. So second trace 5. Got to be my value right there. And so I'm gonna. You want to go to the intersection part to it, then see if you can find where your cursor's at. Hopefully it'll pop up. If you think it should be going the other way, then you go negative till you see it. Sometimes you don't have to, and sometimes it'll make you. Okay, but I'm trying to find my first curve, so I just move my cursor until I find it, left or right. And then I'm going to hit enter, because that's my first curve. And then my enter again for my second curve, it's that red one, and then enter again. So my intersection is negative 1 point, and we're rounding 3 places, negative 1.208, okay, comma y. So if I go over here to my graph, and we're going to have to graph it too. So let's graph it. I'll make this a little smaller now. All right, so when I graph it over here, it's going to look, you have to make it pretty accurate. Don't be lazy about your graphs. So this is my y equals 7 line. And then my other graph, the exponential graph, comes up. Comes up like right around here, and then goes up and intersect, okay? Now the point is negative 1.208, comma 7, okay? And some of your completed notes and homework show that, but the answer, the question is solving for x. You're not trying to graph 2 lines and find the intersection, or 2 graphs and find the intersection. You're trying to find what x is. And this is another way of finding x using your calculator. So my answer is actually just the x. So x equals negative 1.208. Okay? All right, let's try the second one. We are going to put this one in y1 and this one in y2. All right, I'll go to my calculator. Trying to get to work for me. So go y equals. All right, so my first equation is negative, so that's not a negative for us, it's a minus. I mean, it's a negative, but not a minus. Negative 5, and then you can do your caret key, 2x, make sure you're out of the exponent, minus, excuse me, plus 3. And then what? Equals, so hit enter, 7. Okay, caret key again. 3x minus 5. And hit enter. Then we're going to graph. Okay. Now the thing about this one, if you notice, it's pretty, you have to get a really good view of it. So I'm going to change my window. I think I'm going to zoom in a little bit. Just hit enter and see what it looks like. And if you kind of notice, it actually crosses the x-intercept, it looks like, okay? So let's find out if it does that. And so what we're going to do, we're going to hit second, trace, number 5. That is my first curve. So I'm going to hit enter. A second curve, yes, I'm going to hit enter. And then I enter again. Okay, so now we see that if I zoom in just a little bit, notice how the y is a crazy looking number, okay? Well, if you notice, the graph looks like it's getting close to 0. So that is actually a 0 there. This graph does cross the x-axis at, so it has an x-intercept. So we're going to need to look at what that point is. So our intersection here is, oops, we have, sorry, my 0.341, comma, and again, if you have that negative, you have that 4, 3, 6, 2, 1, and then that e, it's a negative number. This is getting close to 0. This e is like scientific notation. It's telling you move your point 4 places this way. And so you would put zeros in there, and it'd be very small number, gets smaller and smaller. So that's what that is doing. Okay, so that would be our intersection. So let's go ahead and draw it. If you hit zoom, if you did what I did and hit zoom 6, you can see it a little bit better, what it looks like now. Okay, so I hit zoom 6 and made my graph out so I can see it a little bit better. So I'm going to erase this part right here. Again, when you see that kind of E, when you see that E, that means it's going, depending on what the decimal is, this was going to the left, so it's getting a smaller, smaller 0. So I know that one graph is going to go up this way. It's kind of on, looks like it's on that x-axis. I mean y-axis, no, excuse me, right, x-axis, kind of close. And then the other one is coming down through here. It's actually crossing right that point. And that's what this point is. Okay, so make sure you draw the graph through. And so my solution is x equals, remember it's just the x value, 0.341. All right, okay, that's the lesson.